Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore one interesting concept related to AWS ECS Fargate, and especially this will be helpful if you are running your batch ETL workloads in Fargate containers. Okay, so I was going through this particular blog where it is basically explaining how Taloflow saved 60% by moving their data pipelines to AWS Fargate spot. Okay, so here lot of things are there related to architecture and all, but one of the major component in this particular blog in which I want to draw your attention is basically this particular part. Okay, so earlier what this particular company was doing, they were running their batch ETL workloads in AWS Glue. Now from Glue they tried to move their existing pipelines in a containerized platform, and they have chosen AWS ECS Fargate. Okay, now in AWS Glue we are having the timeout option, right? That after this much time also, if the job is not getting completed, it is stuck for some reason, AWS Glue service itself will automatically stop or terminate that particular Python or PySpark. That functionality is available there. But when they try to move their existing Glue jobs to Fargate in ECS, there by default these kind of services are not available, and that's what they have mentioned here. That for example, the AWS Glue had a timeout. So if the job gets stuck, the system would come around to forcibly terminate the running jobs, so we would not be charged for running stuck jobs. Okay, because suppose if a job is stuck for some reason at a particular point of your code and it is continuously running and running, that stuck job will obviously charge you, right? Because AWS Glue is a serverless service and it charges for how much time it is running. That is one of the major component, right? So to avoid unnecessary cost due to stuck job, we have the timeout feature in AWS Glue. But when they try to move their Glue jobs to Fargate, then in Fargate, because these kind of functionalities are not available, that's why they needed to use some other services. So that's what they have mentioned here, that however we had to run a timeout manager, right? This is a separate service they had to specifically manage just to have timeout functionality, because by default in Fargate it is not there, and that is 𝐤𝐤𝐸. Basically they are using a scheduler and they are running a timeout manager with the original Fargate task. So this is kind of a little overhead what they are basically utilizing in their code base. Now in our this particular video, basically we are going to explore how we can easily implement a timeout functionality in containerized application. Okay, suppose you have considered AWS Fargate or ECS to run your batch jobs. You launched a task, but to avoid stuck tasks, how you can implement a timeout functionality that after this much time also, if the job is not getting completed, then simply terminate the job, right? That particular functionality, how to easily implement in Fargate with Docker application, that we are going to explore. Okay, so I came across this particular blog where they have explained how we can implement an Amazon ECS task with a maximum lifespan or kind of a timeout functionality. So here it is mentioned, in some cases you may wish to limit how long a task run for. This can be used to prevent a batch job from running too long. The same thing what we just discussed from this particular blog, that same thing here also depicted, the same problem statement they are mentioning here, right? Now to solve that particular problem, what they are doing, basically here if you see, they have given CloudFormation template as well as raw JSON for our task definition, what we can use in ECS, right? So here if you observe that family, network, require compatibilities, etc., CPU, memory, these are default things what we generally mention. Now container definition is especially important part where you can control the timeout for our task. So how they are defining the container? That if you see, container definition is basically an array, right? Now in our earlier videos, whenever we have used AWS ECS Fargate to run batch job or maybe some sort of service, that time in one particular task, only one container, only one Docker image was running, right? And that's what they are doing. If you see container definitions, here first they have defined one 𝐻𝐿 Docker image to run. Okay, so obviously in this task, one 𝐻𝐿 Docker image will be running. Apart from that, if you see, one more container they are defining. So here comes a new concept, that the concept is in a particular ECS task, it is not like that you can run only one container or only one Docker image. You can run multiple Docker images or multiple containers also in a particular ECS task. So that is one learning. Okay, so what they are doing, they are saying you keep your actual code base or business logic in one particular container, okay, or one particular Docker image which you can run in the task, and in that same task you basically define another container to run which will handle this timeout functionality. And what they are basically doing here, if you see, they have given the name of this container as lifespan, and they have taken basically this particular image which is available in public ECR domain. This will help us in executing certain shell scripts kind of thing you can consider. And they are running a command sh-c sleep, and then for how much second you want to run this particular container, that we have to mention. Okay, so using sleep command, basically in shell script or in Python, what we can do, we can halt the execution of a program for certain seconds, right? That same thing, if you see in the main command, they are doing that same operation, that sleep, and then for how much time it will be having a sleep, that they are controlling using environmental variable. So this is how in any ECS task we can configure the environmental variable, as we already know, and there they are mentioning that value as 60. So in short, you can understand that the command what they are executing, that is sh-c then sleep 60. Okay, so this particular container within this particular task will run for 60 seconds and then it will be exiting gracefully. Okay, it is not like it will throw exit code something apart from 0. Exit code will be 0 only, because this code will not throw any error. So after 60 seconds, this particular container will stop. But here is the catch. They are defining essential equal to true, and this parameter plays a very vital role. If you check the AWS ECS documentation about essential, here if I just search, here you will see that essential basically takes a boolean parameter true or false. And what it basically does, let us try to understand that. Suppose that essential parameter of a container marked as true and that container fails or stops for any reason, then all other containers that are part of that particular task are stopped. Okay, and that's the beauty how they are using this essential feature. So what they are saying, within a particular task, you launch two containers. In one place your actual code base will run, and in another container basically you will just have a sleep command for how much second you want to run your whole task overall. Basically it will control the timeout. Now suppose here we are defining sleep 60, that means after 60 seconds this particular container will stop, right, with exit code 0. But suppose for example your actual container which is running the business logic, that is stuck for some reason, that is still running, then because one container is stopped, automatically the other container which is running in your AWS ECS same task, that will also be stopped, right? So this is how we can implement a timeout functionality, that we will be having one container which will run our actual business definition, and suppose to execute that particular business logic, we already know it will be taking maximum 15 or 20 minutes. So what we can do, in the another container we will be keeping this particular value 60 seconds multiplied by 15 minutes, whatever value is there, that much second will be defining here. That way after that much seconds, this particular container will be simply exiting with exit code 0, and because it is also defined as essential true, that's why the other task which is running as a container within our same task, that will also be exiting. So that's the importance of essential true. I hope you are getting this, that using this simple mechanism we can implement timeout functionality in any AWS ECS task. If you are running your batch jobs, then it will be surely helpful. And often these particular containers which are basically attached to any task which is not executing the main business logic, but it is helping our original container which is running the business logic, it is providing some sort of service, right? In those cases, these kind of containers are called as sidecar. So if you see the definition of sidecar, here you will be able to get it, that a sidecar is a container that runs alongside an application container in an ECS task. Okay, so how a sidecar look like, if you recall, generally a sidecar looks like this, right? We are having our original car, along with that one additional attachment is there. So same concept is applicable in Docker. In this particular task, what is happening, we are having two containers. One container is the main container where the actual engine is running. Here in this case, the actual business logic is running. And another container will be there in that same task, which will be controlling the timeout using simple concept of sleep command. Once the sleep command time is over, then it will be simply exiting. That is, this side container will simply be exiting or stopping, you can say. And because it is an essential container, so by default, this main container will also be stopped. That way our overall ECS task will be stopped. And that is the beauty of the sidecar container command. I hope the theory part you understood. Now in our next section, we'll be exploring the practical implementation of the same concept. Stay tuned. So now it's time for demo on how we can create an ECS data pipeline with custom lifespan, or we can say custom timeout functionality. Okay, so for this here I have created a GitHub repository. I'll be sharing this particular link also in the description box so that you can take the code base from here and parallelly practice it. Okay, so here in a typical Docker application, how we generally create, we are having three major files. One is Docker, one is app.py, one is requirements.txt. So first let's explore app.py. So here we are basically doing a simple read activity from an API and we are writing the data in a DynamoDB table. So if you observe here, we are having this API from Coinbase which helps in getting current Bitcoin price. And then here if you check our main function, we are basically making a GET request to get the current Bitcoin price, and that data we are basically first converting to a JSON format like amount, then base, then currency, and then timestamp, at what timestamp we have extracted the data, and UUID. So this UUID will be useful to create a DynamoDB primary key. That's all, nothing else. And then we are calling put item to DynamoDB function, which is basically ingesting the data in a DynamoDB table. In our case, the DynamoDB table name is Bitcoin price storer. So here in my AWS account, I have already created a DynamoDB table which table name Bitcoin price storer, and partition key is UUID, which is basically unique identifier or primary key, which we are ingesting as UUID.UUID4 from our Python code. Okay, right? So if you just check the data now, if I click on explore table items, here you will able to see that there is no data as of now, right? So this is all about our Python code. Now if you check the requirements.txt, here what we are doing, we are importing all the required modules like UUID, request module, URL lib3 to make a request. Boto3 is required, right? Because we need to ingest the data in a DynamoDB table from our Python code. So for any AWS service interaction with Python, we need Boto3, and PyTZ is basically required to get the current timestamp. That's all. And then if you check our Docker file, it is a very simple Docker file. We are taking Python 3.8 base image. We are configuring /app as working directory. We are first copying all the files from our local system to Docker environment in the /app folder. And then we are installing all the required modules and we are running Python app.py, right? This code I need to compile and create a Docker image and push in AWS ECR. So for that, here I have created a GitHub action, a very simple GitHub action. If you observe what we are doing, first I have given my AWS access key, secret key for authentication between GitHub runner and our AWS account, and login to AWS ECR. So for this particular experiment purpose, what AWS ECR repository we are going to use is having name SideCar test. And for that purpose only, if you check in our AWS ECR account, SideCar test with this name, I have already created a ECR repository where currently no image is there, right? Okay. Now if we go back to our CI/CD code, here we are just executing two-step process. First Docker build based on the Docker file available in our current working directory, right? And this particular name we are providing, tagging kind of thing for Docker image, and we are pushing this particular image. So first step is login to ECR, and next step is build, tag and push to Docker image, what generally we perform. Now to run this particular code, the command is given on push. That is, whenever some push activity will happen, that time this particular GitHub action will run. Okay, so maybe to run this particular code base here, intentionally I will make a simple change by adding a new line, and I will commit these changes. Okay, cool. So this step is done. Now if I go to my GitHub account actions, here you will see that one runner is started. So let's go inside that. And here it is now installing all the required modules and creating the Docker image. So here now our GitHub runner actions is complete. Now we can hope that one image should be created here, Docker image. And if I refresh here, you can see one image is uploaded here. And if you see the timestamp, it is 2:51 PM and currently it is 2:52 PM. So that means just now it is installed, right? Now here what we'll do to run this particular image, we need to have one ECS cluster. So currently I am in my AWS Elastic Container Service UI, and I will quickly create a cluster. These all steps I have explained multiple times, so I am going a little bit fast here. So here I can give the name as SideCar Demo YT. Okay, right? And let it be AWS Fargate instance serverless one. I don't want EC2, and simply I will click on create. Okay. So here you can see our cluster is getting created. Meanwhile, we can create the task definition for our batch job. So here I can click on create new task definition configuration. So here first I will give the name as maybe without sidecar. Okay, first we will try to run our code as a normal mode, and then we will see what happens with sidecar. So to understand the custom timeout functionality, here intentionally I have written a piece of code in my Python code. If you observe in the app.py, here I have given time.sleep. Okay, so once data is written in DynamoDB, after that here I am having a sleep time of 10 minutes. So what will happen that this particular batch job, what we are running in our AWS ECS Fargate cluster, will run for 10 minutes, although its main business operation will be completing here itself. Okay, and in our custom timeout related container, which will act as a sidecar, there we can configure maybe 5 minutes, because the expectation is this particular code will complete in 5 minutes itself. Okay, so 5 multiplied by 60, that is 300 seconds we will configure as a sleep time in that sidecar container, and we will observe that once sidecar container gets exited, then this main code also should be exited. Okay, because ideally this main code should run for 10 minutes, but suppose it is not expected for our business code to run for 10 minutes. So if the code gets stuck for some reason, that kind of functionality we are trying to mimic by simply adding a time.sleep. Okay, this will basically act like our code is stuck in a particular place. Okay, and it is not an expected behavior. So we will observe whether custom timeout functionality is basically terminating this step or the code or not. That's how we will observe the demo. So here I will go to my task. So first I will launch a task without sidecar, and let it be AWS Fargate, not a problem. These configurations I am keeping as it is. Now task role. So for this demo I will quickly create one IAM role. If you have one existing, you can reutilize that, not a problem. So here I'll go to roles and create role, and here I want to create for Elastic Container Service, and I want to create for Elastic Container Service task. Click on next, and here ECS. So ECS full access, then ECS task execution policy, and apart from that, obviously it need to interact with DynamoDB. So I am giving DynamoDB full access as of now. Click on next. So here I can give the name as demo YT sidecar. Okay, right? So this is the task, and these are the policies it is having, and I'll create the role. Now I will go back to my task creation page, and here I will search for just now whatever role we have created. Maybe it will not be coming immediately. We need to refresh this page once, and again we need to give the name without sidecar. Okay, and let the launch type be Fargate cluster. CPU and memory I am keeping as default. Task role I will search just now what I have created, and task role, task execution role, both I'll be keeping same. Now first we will inspect without custom timeout how the code is running. Okay, so in this particular case only we'll be having one essential container where our actual business logic is running. So name I can give actual runner, something like this, and image URL. So here if I go inside that, this is our image URI, and I'll be pasting that here. Essential container, yes. Okay, so obviously business logic will be essential container. In the sidecar process we'll be attaching one more essential container. That is the difference. But first we will inspect the demo without the sidecar container, right? So I am keeping only one container as of now. Private registry it is not, and ports and all I am keeping by default. Read only access for root file system, I can check this because this is better for security purpose. CPU memory I am not changing. Environmental variable is not needed, and keeping all other properties as default. I will simply create this particular task. Okay, right? So this is also done. Now I will replicate this in a new tab. So now I will go back to my cluster, and sidecar demo YT, this is the cluster. Here I will try to launch a service, okay, which will basically run our batch job. So now let it be Fargate perform latest service or task. So this is not a service, it is not like 365 days 24/7 it should run. It should just run for a short duration of time. So I am choosing task, and then here family without sidecar I will choose, and then latest version only let me select desired task count 1. keeping all other properties as maybe default like VPCs and all. Public IP you can turn on, as of now not a problem, and I will simply create my task, okay, in our ECS cluster. So if I refresh this screen, here you will see that this task is currently in provisioning status, and if I refresh my DynamoDB table, here you will see that currently no data is available in it. Once our task get executed successfully, what should happen, that in this DynamoDB table there should be one entry, right? So we will see that. So if I refresh, currently the status is changed to pending. So here you can see currently now the status is changed to running. Now we can hope that in DynamoDB table the Bitcoin price should be ingested, and it is ingested successfully, right? So if you see the current timestamp, 2:59 PM 47 seconds, and in laptop it is 3 PM. That means just now it is ingested, right? So the DynamoDB ingestion is done, but still this particular task is keep on running, right? And the reason is basically here I have given a sleep time of 10 minutes. Now suppose this is not an expected behavior. Our business logic should run only for 2-3 minutes. We are already aware of this from historical runs, but still it is running, right? So we need to implement the custom timeout functionality, because by default in AWS ECS that kind of functionality is not available. So for that, what we will do, in this particular task definition, we need to apply sidecar approach. So maybe what we can do, action, and then here, or maybe we can go inside this, and then here you will be getting an option create new revision, and maybe because here directly in the documentation they have given the JSON, I will simply update with the JSON. Okay, so here this JSON it has already created based on our earlier task definition, whatever in version v1 we have created. Just what I will do, I will copy this particular sidecar container from here, okay, right, and I will paste in my code. So here if you see in my task definition, from here the first task definition or actual Docker container information is started, and it is basically ended here. I'll be giving a comma and I'll be pasting this lifespan, which will control the custom timeout. Okay, right? No need to change anything. So what I will do, I will basically create now. So this way our task definition, another division is created. If you go here, you will see V2 and V1. With V1, we have already launched one task. Now here what we want to do, we want to launch a new service or new task, whatever you say. Okay, so I will click on create and let it be default, and it should be a task. So I'll select this one, family without sidecar, that one only, but this time I will choose revision 2, which is having sidecar. Desired task count 1, networking I'll be keeping as it is, and I will simply click on create. Okay, right? So with this, if you see, our earlier one task which was running, which is having 10 minutes as time.sleep, and one more task is launched, in the main business logic we already have time.sleep, but in the sidecar we are having configuration of 60 seconds, and it is an essential task. Okay, so as a result, what will happen, within this task 2 container is running, and the container with sidecar which is having 60 seconds as sleep time, that will be basically exiting with success code 0. But the first task where actual business logic is running, that will still not be completing. But because sidecar is essential, so overall whole task will be coming out. Okay, so you'll observe that. So here if you refresh the status, currently it is pending. In our DynamoDB, we are still having only one entry. Once this task will be in running state, we'll see what is happening. Ideally in DynamoDB, one more row should be ingested, because here if you see, the code is pretty much simple. So from beginning till the data ingestion of DynamoDB, it should be completing within 1 minute, and then our sidecar will be coming out with exit code 0. Okay, so let's see. So currently it is running state. Here if I refresh, here you will be able to see one more row is ingested, and it is having 15:03, that is 3 PM 3 minutes 59 seconds, and currently it is 3 PM 4 minutes. That means this particular row is just now ingested, and because Bitcoin price get continuously changed very rapidly, so earlier it was 93,988, now it is 93,925, like that. It gets continuously fluctuated, right? So anyway, that is not our main point of discussion. We should see now that this particular task which is launched with our second version of task definition, that should be terminated. So if I refresh the status, still it is running. I can maybe go individually within each task and show you how it is happening. So here first in this particular window we are having previously running task. If I scroll below, here you will see only one container is running, actual runner. But if I open the second task, right, here you will see two containers are running. One is actual runner, one is lifespan. Actual runner, there our actual business logic is running. But in lifespan, our sidecar container is running, we can say, right? Now if I refresh, here if you see, our actual runner is still running. But lifespan, this particular container which is controlling the timeout, that is stopped with exit code 0. It is not an error. It just exited because sleep time 60 seconds is over. But because it is an essential task, so our actual container which is running actual business logic, that will also be getting exited. So let's see if I refresh. Yeah, still it is running. It should be stopped immediately by AWS ECS. And here if I refresh again, here you have seen that from running, it abruptly went to stop. Exit code 137. Exit code non-zero, that means there is obviously some problem. And what is the problem? This particular code is stuck due to our time.sleep of 600. That means for 10 minutes it is stuck. So kind of we tried to mimic our real world scenario where our ETL pipeline suddenly got stuck at certain stage. And it ideally should take 2-3 minutes, right? So there is no default timeout functionality. So using lifespan we have controlled, right? And if you check the logs here, you will be able to see exit code 137. Essential task is exited, right? But on the other hand, our first task, whatever we have launched without any sidecar, if you see, it is still running, right? Because it is having actual runner. It is, apart from business logic, it is not having any sidecar which control the timeout functionality. And this is how using timeout you can beautifully save the additional cost what sometime may incur due to job stuck at a certain stage, right? So I hope you understood this. I will suggest you to do the same experiment. All the code base and reference links I'll be sharing in the description box or in the comment section. If you have any doubt at any stage in this video, just ask in the comment section with the timestamp. I will surely try to reply back ASAP. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.